Okay, people tend to get this mixed up. In the x-axis means that's where the mirror is. It means you're reflecting this way. It's a vertical reflection. Points are switching that way. The y-coordinates are changing. Okay, this is a vertical reflection. When you say in the x-axis, it's the way the mirror is, right? When you look in a mirror on the wall, the mirror is vertical, but you're looking horizontally, right? Like the reflection's happening horizontally, even though the mirror is vertical. This is across a horizontal line, but the reflection is vertical. That point's going down here. This point's going up there, and so on, right? So if you drew the thing, it would look something like this if you were more skilled than I am right now, obviously. But I think you get the idea, right? Where do I find this computer? If you draw the thing, that's one thing. You have to be able to draw the reflection. But you also have to be able to come up with the equation if it's like that. This is very poorly done. You'd probably want to put a few more to get the shape right, but... Okay, so approximately like that. That's what the curve looks like. So we're going to have to change it slightly where you have to draw it yourself. To come up with the equation, write the equation. This is something people find difficult here. If you want to take this, you take any function or any relation you want. If you want to reflect in the x-axis, what you need to do is you need to replace what with what. If we want to reflect in the x-axis, as in vertically, what do we have to change? You got two choices here. X with negative x, y with negative y. Which one is it? Yeah, if you want to do it vertically, you need to replace y with negative y. So you take this equation here and you just replace this. You do this. Okay, you keep everything else the same. That'll reflect you in this vertical reflection here. So of course you could write it as this, minus... Now actually, if you look at this, this has a particular kind of symmetry that if you reflect it in the y-axis, or in the x-axis, you get that shape. But if you reflect this in the y-axis, you get the same shape. What would we have to do to this function to reflect it if we wanted to reflect it in the y-axis, as in horizontally? I'm going to write it up here. What if we did it horizontally? What do we replace? You don't replace y with negative y if you're doing it horizontally. If we're going to reflect it in the y-axis, this is not on your sheet. Maybe that's why you're not saying something. Yeah, change x to negative x. If you were to replace in this function here x with negative x, it would be 5. But instead of x here, I'll write the x so you actually see the replacement. Because it's just so exciting, right? That changes to, what does it change to? Negative x. So instead, and of course you have to put brackets here so you don't do silly stuff. And this one turns into negative x. How would I simplify that? I'll write it over here. I've got, on the top I have 5 times negative x, which you would probably write as negative 5x. On the bottom I have negative x to the second power plus 1. Negative x to the second power, if I have a negative number to an even power, what's that going to be the same as? It's going to be the same as that, a positive, right? This is actually, this negative here disappears, right, when you raise it to an even power. Do you notice then that this function is the same as this function algebraically? You get the same result algebraically when you replace x with negative x as when you replace y with negative y. You get the same thing. And that makes sense because the picture looks the same if you reflect it horizontally or vertically. Right? If I say what kind of a reflection is this? I don't know. It could be that this point went there and this point went here. Or it could be that this point went here and this point went here. It could be horizontal or vertical there. And the equation turns out the same. That's not always true. If I was to reflect this thing horizontally and vertically, do I get the same thing? If I reflected this vertically, it would look like this, right? It would go something like this. That's reflecting it vertically. If I reflected it horizontally, it's going to look something like, not anything like that, but it's going to look something like, that's that part of it, and then it's going to go up and over and up like that. So it's going to be something like that if you reflect it horizontally. It's going to be different. I would like you to reflect this two ways. I want you to reflect it horizontally in the y-axis, and I want you to reflect it vertically. You don't have to draw it, but you have to come up with the equation. Vertically in the x-axis. Two ways. We're going to put that on hold, though. You can do that after lunch, because for these people who are leaving for this GQ thing, I want to talk about the expansions and compressions a little bit.